Okay. All right. Good morning, all. Are you able to hear me?
Yes, sir.
Okay. All right. Okay. Just giving a couple more minutes for other persons. Let's see here. Thompson. Okay. While we wait, another minute or two, you could just read this information that's coming from page 289 of your text. That's the first thing we're going to start off with this morning. Discounting interest-bearing note before maturity. You could just read through that, and we're going to discuss that first thing for this morning. Okay, so guess we can begin now. So last class we were looking at we finished off looking at in discount notes, simple discount notes, and we did a comparison between simple interest notes and simple discount notes, and we also looked at promissory notes. So we didn't quite finish chapter 11. So the last part of chapter 11 is looking at dealing with interest-bearing notes. As the topic says, discounting the interest-bearing note before maturity. And so on page 289, you will see an explanation as shown on your screen as to what companies sometimes do if they have a note from another company. So one company owes another company, and sometimes they cannot wait until the due date for the note of when the note matures, so they can take the note to a bank and cash it in. And so they could have cash for whatever purpose they need it for, and they'll have the cash before the note is matures. Okay, and so when the note matures, then the person whom they owe would be paid. Okay, so the steps for that also appears on page 289 of your text. And so the first step is to calculate the interest and then the maturity value. Then you need to find out how much time the bank is going to hold the note for. And work out the discount, how much the bank is charging for the note, and then how much you will get after the bank take out their discount, or that's which would be the charge. So we have an example using the same company that is mentioned in the first slide. All right, so they got a note on March 8th, and the face value is $2,000. So they owe $2,000. They have 185 days to pay for the note. The interest rate on that note is 6%. Now, when they take it to the bank is going to charge them 5% interest for cashing in the note. And they took the note in on the 9th of August. Okay. So you're asked to say, okay, what is the interest and maturity value, which is step 1 of the procedure. Then you're asked to find out what is the discount period, which is step 2 of the procedure. Then you're asked to do the bank discount, which is step 3. and the proceeds, which would be step 4. All right, so we're looking at the working for that. So the details are at the top here. So the first thing you ask for is the interest and maturity value. So interest is principal times rate times time. So in this case, you have the face value 2,000 will be your principal. The interest for the note is 6%, and the note is for 185 days. So we're using ordinary interest. So when that is multiplied, you get a total of $61.67 for your interest. The maturity value would be the 2,000 plus the 61.67. So at the end of 185 days, they should pay $2,061 to the company, which they owe. But they are going to take this note to the bank, okay, before it is due to mature. So the time that the bank is going to keep the note for is called the discount period. So we need to now work out, if they take this note to the bank on August 9th, how long is it that the bank will hold it for? Because the bank is going to charge interest on that time period that they're going to hold the note for. The bank is not having it for the full 185 days. They're going to have it from August 9th until the date that the note matures. So on August 9th, if you use that calendar, which is found, I think it's page 189 of your book. Page 180. Yeah, page 187, page 187 of your text. You will see that August 9th is 221st day of the year. And March, when the note was written, is 67th day of the year. So when you subtract, you would get 154. So this company had the note for 154 days. So how many more days are left on the note? You subtract that 154 from 185. And so the bank is going to be holding that note for 31 days. And so that is how they're going to work out their interest. Their interest will be for 31 days of holding the note, and their rate of interest is 5%. Okay. So we'll finish step 2, which is to find out how many days the bank is going to hold the note for, which is 31 days. And just a diagram to show how that's worked out. So the note is for 185 days, but the company had it for 154 days. So to find out how long the bank is going to have it for, you have to subtract that 154 from 185, you get 31. So the bank will have the note for 31 days before it matures. And the company that provided the note will have to pay the bank the full amount of the note. So we move then. Okay, this is another way. If you don't have the table, you could work out manually. But I'm not going to look at that. You'll have the PowerPoint to look at it later on, but you could also do it manually if you don't have the table. But for the questions you'll be doing, you should have access to the table. So the next step now is to calculate the bank discount. So the value of the note, actually the maturity value is 2,061.67. The bank is charging 5% for holding the note, and they're holding the note for 31 days. So we use those figures to work out the interest that they're going to charge. And in this case, it comes to $8.80. And so they are going to take that $8.80 out of the full value, maturity value of the note, which is 2,061.67. And so what is left is what the company that's discounting the note, that is what they're going to get. Okay, so the company that took the note to the bank will get $2,052.87. And when the note matures on day 185, the company that wrote the note will pay the bank the $2,061.67. And their interest will be included in that. Okay, so that's the steps there for discounting a note before the due date. Any questions on that? You think you are clear?
I have a question, Mr. Allen, please. Yes.
Go ahead.
Okay. I see how you calculated the 2,052.87. I see how you got that. What you're saying is that's what the company will get?
Right. So the company that had the note, they will get 2,052.87.
Right.
If they had waited until the note mature, which is after 185 days, they would have gotten 2,061.67. But they couldn't wait, so they took it to the bank, and you could say sold it to the bank, but the bank is going to charge them interest. So the bank is going to charge them interest based on their interest rate and how long they're holding the note for. So there are 31 more days left on the note. So they're going to charge based on the maturity value of the note, their interest rate, and the time they're holding it for. And so once they work out that interest, they will take it away from the full value of the note, the maturity value, and the company that traded the note with them, they will get, that will be their proceeds. And when the note matures, the company that was owed will pay the full amount, which is the 2,061.67. Okay. So those are the steps involved there. So we'll look at one next. So let's look at this one. So we're going to start off. It says, from the information below, calculate the interest and maturity value, discount period, the bank discount, proceeds, assume ordinary interest. So this company has a note that was written April 10th. The note is for $40,000. So this note is for 170 days. So they have 170 days to pay this $40,000. And they're being charged 5%. Now, they took it to the bank on June 10th, and the bank is going to charge 2% for holding the note for them, or cashing in on the note, okay? And that 2% will be based on how long the bank is going to be keeping the note for until it matures. So step one is to find out the maturity value. So we have to find out how much interest is due on that note after 170 days, 40%. Sorry, $40,000 is the face value. So how we're going to work out the maturity value. Eight, five,
First,
one.
you have to find the interest.
First, okay, so how we define the interest?
40,000 times 5% times 170 over 360.
Okay, this is Ms. Thompson. Okay. Okay, so 40,000 times 0.05 times 170 over 360. Okay, so we're finding the interest. So when we multiply that,
$944.44.
all right, so that's our interest. So the maturity value then, this is your interest, I equal maturity value then would be the 40,000 plus the 944.44, which is equal to 40,944.44. Okay, so if the company had held the note for the full period of time, when it is matured, they would get $40,944.44. But they're going to discount the note because whatever they need the cash. So they discounted it on June 10th. So we need now to find out how long is the bank going to hold it for, and that's called your discount period. So how are we going to find the discount period?
You have to consult the calendar, so it'll be
June 10th.
which is 161.
Okay, 161 days.
April 10th, which is 100.
April 10th, 100 days. So when you subtract 161 minus 100, you get 61 days. Okay. So the note is actually for how many days?
170.
170. So therefore, then your discount period would be equal to 170 minus 61, which gives you
109.
okay, 109 days. All right, so the bank is going to hold the note then for 109 days. And so that's how they're going to work out how much to deduct from the maturity value of the note to work out your proceeds. So the bank discount then, bank discount called BD, would be the maturity value, which is 40,944.44, okay, times, what's the interest rate?
2%.
2%. The bank is charging 2%. Okay. And the time would be
109 days.
109 over 360. Okay. So once we multiply that, that should tell us how much the bank is going to charge for interest.
$247.91.
Okay, so that's your bank discount. And so to get the proceeds, how much you will get for discounting the note, it would be the maturity value, which is 40,944.44 minus the 247.94. So that's equal to 40,000.
40,696.50.
Okay. So not waiting until it matures, you get 40,696, and the bank will get 247.94 once the note matures and the company pays them what was owed to you. And so that's that. Of course, this kind of procedure is not very common these days because a lot of companies now they have lines of credit directly with bank, and so rather than getting a line of credit from another company, they could just use their line of credit from the bank to make the purchase. But we do have some situations where companies do promissory notes and take it to the bank for, but it's not as common as it used to be. So that would be the procedure that would be used there. Any questions with the process? Ms. Hield, you following? Are you there? Ms.
Yes,
Hield?
sir, I am here. No questions.
Okay, Mr. Butler?
Hey, morning, anyhow.
Yeah, you're following so far?
Yeah, I just took a screenshot of it just in case.
Okay, Ms. Knowles?
I'm here.
Okay, you following so far?
I am.
Okay, how about Ms. Roll? Somebody's, Ms. Roll isn't with us anymore. Let me see. Okay, I don't see her. Okay, all right, so Ms. Roll out. Partial. Okay, all right, so that was the last portion of chapter, that's chapter 11 on promissory notes, which is the section that deals with discounting the note before it matures. Okay. So you have two questions there for homework from that chapter, part 2. So it's page 296 to 97, questions 3 and 4. And the questions are right on the PowerPoint. So that will be emailed to you after the class. You could attempt those too. I think the answers are right here. So if you do it, you're not able to get the answers, then you could always bring it to our attention for next class. Okay. All right, so our next chapter is chapter 12, which we're going to try to see if we could finish today. And in chapter 12, we are looking at compound interest and present value. So far, our focus have been mainly on simple interest, but these days, most of the interest that is involved in business calculations is actually compounded interest. Okay. And compound interest is sometimes referred to as future value. You'll see that in your book. They use the term future value. So when they use the term future value, they're actually referring to interest that has been compounded. And so when we talk about compound interest, essentially what we're looking at is interest added to principal and calculating interest on that sum repeatedly. So compound interest, it says the interest on the principal plus interest of prior periods. With simple interest, we don't add the interest onto the principal to calculate interest. We basically just calculate the interest on the principal. Okay. So we'll look at one or two examples to show the difference between the calculation for compound interest and simple interest. So later on, we'll look at present value, but let's just focus on the future value for this time. Now, when you're looking at compound interest, you will find that there are some terms that are frequently used. Compounding can take place on different periods: annual, semi-annual, quarterly, monthly, or in many cases, daily. With computers now, a lot of times the interest is compounded daily and then just reflected on either a monthly basis or a quarterly basis. So I think all these terms you should be familiar with. So we could move on. So here now we are looking at a comparison of compound interest and simple interest calculation. So we have the same scenario in both of these questions here, where it says that this person deposited $80 in a savings account for 4 years, and they have an annual interest rate of 8%. What is Bill's simple interest and maturity value? And then this other one says, what is Bill's interest and compounded amount? Okay. So, so with the simple interest, our principal is $80, and we find 8% of that for 4 years. And it works out in this case to $25.60. So with simple interest, you simply, whatever the rate is, you simply find that percentage of the principal and you multiply by the time and you get your interest. To find the maturity value, you simply add the interest to the principal, and that's it. Simple process. Now, when it comes to compounded interest, my chart didn't copy to correctly, but you should be able to see the process there. So what they do with this compound interest, we find the 8%. So we do it year by year. So the principal changes every period for compound interest. With simple interest, the principal remains constant. Whatever your principal is, that's it. It doesn't change. You don't add anything to it. You only add to kind of the maturity value. But in the compound interest, if the compounding period is annual, then every year you're going to find that percentage. So in this case, it's 8% of 80, which is $6.40. You add the $6.40 to the $80. And so at the end of the first year, your principal is $86.40. So when it comes to year 2, you're going to now use that $86.40 as your principal and find 8% of that. With simple interest, every year, your principal will be the same. So year 1 would be 80, year 2, the principal will be 80, year 3, your principal will be 80, year 4, your principal will be 80. So the principal doesn't change unless you added more to it to increase the principal, but it's not going to be changing due to interest. When you do compound interest, the principal changes each year or each period due to the interest that is earned. So you earn $6.40 interest in year 1. So your principal now increases to $86.40. So in year 2, you're going to find 8% of $86.40, which ends up being $6.91. You add the $6.91 to your principal that you had at the beginning, which was $86.40. And so your new principal now is $93.31. And so year 3, that's going to be your principal for the start of that year. Then you find 8% of that, which gives you $7.46. You add that to the principal that you had at the beginning of the year, and now you have $100.77. Okay. And so the beginning of year 4, your principal will now be $100.77. You find 8%, my 8 got chopped off there. And so your principal, your interest now is $8.06. You add that to the $100.77, and you get $108.83. And so at the end of year 4, you will have $108.83. And so if you want to find out what your interest earned for the period was, it would be $108.83 minus what you start with, which was $80. So you earned interest of $28.83, which is slightly higher than what we had here, which was $25.60. So when you compare the two, you'll see that the compound interest actually gives you a better return than the simple interest, simply because every time you get interest, that interest is added to your principal. And so you get a new principal at the beginning of each period. And so when you calculate the interest for the next period, it's going to be based on your principal plus interest, and the process continues. Okay, so that is the sort of advantage of the compound interest. Okay, and reflecting the difference between the two. Now, in the question that we just looked at, we were doing interest on an annual basis. But interest doesn't necessarily have to be calculated annually. And as you can see earlier, we have some different time periods that we're looking at. Okay, could be annual, semi-annual, quarterly, monthly, or even daily. But most times the interest is stated per annum. So when we are calculating the interest in a question, we have to be mindful of the fact that it is stated annually. So in this case, you're given, if your compound interest 4 years, 8% annually. But if the interest is calculated or paid out semi-annually or quarterly, we cannot use that 8% each time we're calculating the compound interest. We have to look in terms of what time period we're doing the calculations. So you will see here in this section, they refer to number of periods. So the number of years multiplied by the number of times the interest is compounded per year. So if you have a question like this one, which says if you compounded $100 for 4 years at 8% annually, that means that annually, each time you're gonna have 4 periods, okay? Because it says number of years multiplied by the times the interest is compounded. So it's only once a year, so it will be 4 periods. The rate for each period, the annual interest rate divided by the number of times the interest is compounded per year. So it's only once you're compounded because it's annually, so 8 divided by 1 is 8. So the rate per period here would be 8. So this would be 4 periods. And the rate per period would be 8% per period. Now, you will see here, so right here, this is what we had, 4 periods, and then 8% per period. But if you are compounded semi-annually in the second row, if it's 4 years and you do it twice a year, semi-annual is twice a year, you're going to end up with 8 periods. If it's 8% and you're compounding twice a year, you divide the 8 by 2, it's going to be 4% each time you do your compounding. Then for quarterly, if it's 4 years and you are doing it 4 times a year, then you're going to have 16 periods. That means you're going to compound your interest 16 times. And since the interest rate is 8% and you're compounding 4 times a year, each time you compound, it will be 2%. For 8 is 2. Okay, so you have to be mindful of that when you are doing your calculations for compound interest. So the example that we looked at, we were just dealing with compounding once a year, but if you're compounding more than once per year, then you have to adjust your periods and your rate based on how many times a year you are compounding. And we'll look at some examples to explain that further. Okay, so let's look at this question here. You have a principal of $1,600. The time is 2 years. You're compounding. Your rate of compound is 6%, and you're compounding semi-annually. So let me ask Mr. Butler, if we are compounding 2 times a year, because semi-annually means twice a year, and it's for 2 years, how many periods will that be?
2.
Okay, twice a year for 2 years. How many times are we going to be compounding?
My bad, 4 times.
4. So the number of periods will be 4. Thank you. So it's 4 periods. So if we're going to do the calculation for this manually, we'd have to do it 4 times. All right. So Ms. Knowles, what would be the rate that we'd be using for each period?
0.06%.
Okay. So listen to the question now. You have a rate of interest of 6% per annum, but you're compounding twice a year. It's 6% per annum, but you're not compounding per annum, you're compounding twice a year, which is semi-annual. So how much interest you're going to charge for each period? You're not going to charge that full 6% for each period because you're compounding twice a year. So what would it be per period? You follow me, Ms. Knowles?
I trying to.
Okay. The 6% is for a whole year, but we're not compounding annually, we're compounding semi-annually. How many times is semi-annual? How many times a year?
Twice.
Right, so if it's twice and you are doing 6% for the year, how much should it be for half a year?
6 months.
How much interest? The 6%. If you have to do half a year,
30%.
3%, right? 3%. So you have to look to see how frequently we are compounding. So we're not compounding annually. If we're compounding annually, then the rate would be 6%. But because we are compounding semi-annually, each time we compound, it would be 3%. So what this question is saying to us now is that if we want to work out the interest for this, we'd have to do it 4 times because it's 2 years at twice a year. That would be 4 periods. And each time we work out the interest, we'd use 3%. So you would start off and say $1,600 times 0.03. 3% of 1,600 is how much?
$48.
Okay, $48. All right, so that's $48. Now, because we're doing compound interest, you're going to add that to 1,600. So that would be 1,648. So at the end of the first period, so we don't say first year because we're doing it semi-annually. So period 1, we're going to have 4 periods. Period 2, and each period in this case is a half a year. Period 2, and we have period 3, and then period 4. So when we go to period 2, our principal is now going to be 1,648. Because we did the first half year, and since it was half year, we're going to use 3% instead of 6%, because we're doing half of the year at a time. We're going to find 3% now of this 1,648. And when you find 3% of 1,648, what do we get?
49.44.
Okay, 49.44. And we're going to add the 1,648 to that.
$16.97.44.
1,697.44. Okay, so that's the end of period 2. And by the way, that would be the end of year 1, because remember, each period is half a year because we are compounding semi-annually. So now when we go to period 3, which is the beginning of year 2, our new principal is going to be 1,648. 97.44. And we're going to find 3% of that.
$50.92.
Okay. And we're going to add the 1697.44 to that.
$1,748.36.
Okay. All right. And then for the last the last period, we're going to use that now as our principal. 1748.36 0.3, multiply that. Oh, sorry, not 0.3, 0.03. Okay.
52.45.
2.45. And we're going to add the 1748.36.
$1,881.
1,000. Say that again.
I got $1,800.81.
Okay. 1800.81. Okay. All right. So that would be your final amount at the end of 2 years, which would be 4 periods because we are doing it twice a year. Okay, so if you wanted to find out the interest that you got, you would do what? How much interest was earned for this investment?
Would
We
you
ended up with,
add all the
Add
interest?
all the totals.
okay, that's one, but what did we start with? What did we end with?
Subtracting. Subtract the
Okay.
1,800.81 from the 16.
Okay, so 1800.81 minus 1600, and so that should give you $200.81, and that would be the interest earned. So this in the book they refer to that $1,800.81 as the future value, or the compounded amount. And then this here would be your compound interest, or just your interest. Okay. Now, suppose this was simple interest. How much would you earn? How would you calculate simple interest on this? $1,600, 2 years at 6%. What's the formula for simple interest again?
Times rate times time.
Okay, so it would be, so the simple interest, I put SI, would just be 1,600 times 0.06 times 2 years. So how much is that?
$192.
Okay, 192.
Question, why you use 6 instead of 3?
Because we're doing simple interest. Simple interest. I'm just trying to show you the difference with the simple interest versus compound interest. With simple interest, it's your principal times your rate times your time, and that's it. We're not going to be adding the interest to the principal. We just, whatever your principal is, you're going to multiply by the rate by the time, and that's it.
Okay.
And so you get 192. So in the case of the compound interest, you get $200.81. And of course, the reason for that is because you are adding your interest to the principal, and then you're finding that you're getting interest on the principal plus the interest, and you continue doing that over time, and so you end up getting a difference compared to simple interest, where all you're doing is finding the interest on the principal only. You're not adding that interest to the principal and then finding principal interest on that. Okay, so that's the difference between the two. So we did the manual method for working out the compound interest, but sometimes, you know, compound interest is used for many types of calculations, like mortgages. When you pay your mortgage, that is compound interest that's been used, and that could be as much as 30 years. And so if you have to do a calculation like that for 30 years, it's going to be very tedious. So there are multiple approaches, okay? So one approach that could sort of shorten the work is to use tables. So they have what they refer to as, let me see which page is that, 304. 304. They have the compound interest table in your book on page 304. Okay, this compound interest or future value table. So you could use the table to help you do your calculation, or you could use a formula. This is a formula right here. A equals P times 1 plus I to the nth power. Okay, so those are two methods that you could use to avoid having to do all this calculation. And this is just because this is only 4 periods, it's not too bad. But if you have 20 or 30 periods, then it would become very cumbersome to do that kind of calculation. So to shorten the work, we could use a table, or we could use the formula. So we're going to use the table and formula to do, I guess, the same question, but let's look at the steps. It says here, find the periods, that's the years, multiplied by the number of times the interest is compounded. Find the rate, which is the annual rate divided by the number of times interest is compounded in a year. Then you go down the table, and it says, go down the period column of the table to the number of periods desired. Look across the row to find the rate. At the intersection of the two columns on the table is the table factor. And then once you find the table factor, you're going to multiply the table factor by the amount of the loan. All right. So if we look at this here, our periods was 4 and our rate was 3%. But if we go down this table, what did I say again? 4 periods and 3%. So 4 periods, just going along here, and 3%. So the intersection is right here. So that says 1.1255. So that would be our table factor. Okay. So if we go back to that question, let's see, 1.255. That's your table factor. And you're going to multiply it by the principal, which is 1600. So I want you to multiply 1600 by 1.255. See if we were correct in what we did.
I got $2,008.
Hold on, did I look at the right thing? Oh, sorry, I wrote the wrong thing down. Sorry. It's 1.1255. Sorry about that. 1.1255 times 1600.
1,880 cents.
1,880 cents.
Yes.
Okay.
0.8.
All right. So see what we got earlier, 1,881 cents. All right. So it's slightly off because of rounding. Okay. So the table will give you a fairly close answer because the table is actually rounded to 4 places. If you do the manual calculation, once you are doing it correctly, you make no mistakes, your answer would be more accurate than what the table gives. The table rounds off the answer to 4 places. So it wouldn't be as accurate as the manual calculation, but it gives you a reasonably good answer. So using the table, we were able to get $1,800.80 as the compounded amount or the future value. And if you want to find the interest, we simply subtract the 1,600 from that, and we'll get, in this case, we get $200.80. Okay, so that's how we use the table. Now, if we were using the formula, let's look at the formula. The formula says A equals principal times 1 plus I to the nth power. So in this case, it would be A would be equal to, the principal was 1,600, and then 1 plus the interest per period for that question was 0.03. So 0.03, and the number of periods was 4. So that would be n would be to the 4th power. All right. So that would be equal to 1,600. 1 plus 0.03 would be 1.03 to the 4th power. So what you would do then, you would go on your calculator and you would multiply 1.03 4 times. When you multiply 1.03 4 times, what do you get?
$4.12.
No. Oh, no. Oh, you multiplied times 4. That's to the 4th power. The 4th power means you're going to say 1.03 times 1.03 times 1.03 times 1.03. Anybody did that? When you multiply
1.125. That's the same as the
1.55.
interest rate from the calculator machine. the
Okay,
paper.
so it's going to be 1,600 times 1.125508881. You'll notice that it's similar to, as someone said just now, to what we got on the table. But you see the table run it off the 4 places. But if you did the actual calculation, you will end up with more than 4 places. So what you would do now, you would say 1,600 times that, and that would give you $1,800.81. All right. So the formula actually gives you a more accurate answer than the table, but the table is a quicker way to work out this compound interest. Okay. So that's the use of the formula there. But whether you're using the formula or the table, you need to make sure to find out the number of periods and the rate per period to use for either the table or the formula. Okay, so let's move on then. All right, so we have another example here. This person deposits $8,000 in a savings account that pays 6% interest compounded quarterly. What will be our balance? What will be the balance of our account at the end of 5 years? All right, so we're looking at compound interest. It says compound. So because we're looking at compound interest, we need to know number of periods. It's 5 years and it's compounded quarterly. So that's 5 times 5 years, 4 times a year. So that's going to be 20 periods. It's 6% compounded 4 times a year. So how many, if you divide 6 into 4 parts, you're compounding quarterly, you get 1.5% per time. So you go to the table and you look for 1.5% for 20, 1.5%, see this is 1.5 here, go down to 20, you see that? 1.3469, and that's what they have here, 1.3469. And so the compounded amount then would be the 8,000 which you started off with, times that 1.3469, and that gives us $10,775.20. And so that would be the compounded amount. Suppose you wanted to find how much interest she earned, what would you do?
8,000 times 6% times 5 years.
No, that's trying to find a simple interest. I want to know how much interest did she earn from this investment.
10,775 minus 8,000.
Okay, so you're going to take away the 8,000 from the compounded amount, which is 10,775.20. But if I said, you know, find the simple interest, then you would say 8,000 times 6 times 5, 6% times 5. But I just wanted to find out how much interest she earned from this investment. Now, if you wanted to use the formula to do this, the formula again is amount equals principal 1 plus I to the nth power. What would you put in the formula? Let me hear. A equals what? What is P?
8,000. A equals 8,000.
Okay.
Open
1
bracket.
plus I would be what?
1.5.
Okay, 0.015.
Sorry, yeah.
And then N would be
20.
20. So that would be 8,000 and then 1.015 to the 20th power. Now, this can become tedious You have to say 1.015 times 1.015 times 1.015 times 1.015 times. You'd have to do that 20 times. But you have a shortcut to do that. How could you shortcut that? Anybody? Mr. Butler? Are you with us, Mr. Butler?
Yes, I'm here.
Yeah, it's asking if you, how could you shortcut that instead of multiplying 1.015 by 1.015 by 1.020 times? What key on your calculator you could use to shortcut that?
The power 2.
The power key. Okay. Now,
Yeah.
if you're using a simple calculator, those simple calculators don't have the power key. But if you have a scientific calculator, the scientific calculator would have the power key. Okay. And so you could use that to shorten that so you wouldn't have to do that. And the power key is this key that some calculators have it as x to the y. So you would put in the 1.015 and then press the x to the y key, then 20, and then it would give you the so let me see it on my calculator. Let me see. Some cell phones do have it, but of course, you remember now you're not going to be allowed to use cell phone in your exam, so you need to have a scientific calculator for that. So if you enter 1, where's the point on this? 0.015. 0.015. Then you press that power key to the 20th.
20.3.
I get 8000 times 1.34 1.3468555066. Okay, and then you multiply, and you notice that with this is yeah, it's kind of close to the table factor. They just run it up to 4 places, so that 5 would make this become 69. All right. So if you have a scientific calculator, you could use that to work that out instead of having to multiply all those numbers of times. Okay, using the power key. All right. Okay, so I'll let you do this one. You could choose whichever method you, hold on, this is the same. No, sorry, this one we did already, I think. Let me double check. 16, yeah. All right, so we're gonna move to, okay, I give you a couple minutes to do 12-3. Do 12-3. So the first thing you need to do is find the number of periods and the rate per period. So what is the number of periods for 12-3? Hmm?
Is it 2?
If it was 1 year, it would be 2, but it's not 1 year. What fraction of a year is this?
It's half a year.
half a year. So when you to find the number of periods, it's the number of years times the times per year. That's how you find the number of periods. N equals years times number of years. So that in this case, it would be half a year, and semi-annual is how many times a year?
Twice.
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 So 2 times half. 2 times half gives you
1.
1. Okay, so the N for that one would be equal to 1. And then the rate per period is how much in this case for 12-3?
Would it be half of the 6?
Half of the 6, which would be equal to 3%. Okay. Okay. So you would go on your table and look for 1 at 3%. Now, I don't know how many of you have the table, so let me just go to the table and tell me 1 period, 3%. Tell me what the table factor is for that.
That's 1.0300.
Okay, 1.0300. So the table factor here, 1.0300. All right, so if that's the case, then how would we work out the compound interest? We're going to multiply. Future value equals what's the principal?
It's a 15,000 by the 1.0300.
Okay, right, times the 1.0300, which gives us how much?
$15,450.
Okay, so that's your compounded amount. So they want the compounded amount, which is 15,450, and then they also want the interest. How much is the interest? Not the simple interest now, just the interest on that investment.
450.
$150.
Yeah, 450.
Okay. All right, let's look at the next one, 12-4. Number of periods for that one.
Three times 2. 3 times that'll be 12.
Okay, 3 4s are 12. Okay, 3 times 4, 4 times a year, 3 years, that's equal to 12. And the rate per period.
That'll be 6 divided by 4.
So that would be 1.
1.5.
Okay, 1.5 or 1.5%. So we need to go to the table, look for 12 periods at 1.5%. 12 periods at 1.5%, and what that should be.
One
Point
point
1960.
Okay, 1.1960. Okay. All right, so the table factor is equal to 1.1960. So the future value, which is your compound amount, would be the 6,000 then times that 1.1960, which gives us
$7,176.
7176.
Yes.
Okay, so that would be right here then, 7176. And so the interest then,
1,176.
okay. All right. Okay, let's look back at the first one, 12-2. What would be the number of periods for that one?
Is it 12?
Okay. You tell me, is it 12?
I think so.
Okay. All right, because it's only once a year and 12 years, so 12 times 1 would be equal to 12. And what would be the rate per period?
Three and a half percent.
Okay, 3.5. You're only doing it once a year. So annually, so 3.5 divided by 1 is 3.5. So you go to the table, 3.5 for 12. Oh, our table doesn't have 3.5. Okay, so we wouldn't be able to use it. Now, if you some of the books came with an extra workbook. You'll see a note at the bottom here, a handbook. The handbook would have a wider range of numbers than the table in the book. It should have 3.5 and other denominations. Okay, but in any event, if you wanted to do this, you could use the formula, and that would help you to answer questions like this. But for your exams and tests, we're going to make sure whatever figures we give you, the table that's provided would have those figures. Okay.
You
Okay.
still
So
thought it was in the extra book?
could you repeat that?
You said that the 3.5 was in the extra book that came with the book.
Yeah, there's a small sort of manual, I think it is called. Let me see what they call it here. Business Math Handbook. Yeah. I think it has a wider range of values than what is in the actual textbook itself. All right. Okay, so not to worry if you don't have it though, because like I said, for tests and exams, we provide the table, and we'll make sure that whatever is asked, that value is in the table that's provided. Okay. So in the previous section that we looked at, we looked at this term effective rate. You will find that a number of times when we do some of these calculations, there is a stated rate that the bank gives, but when you calculate the effective rate, sometimes you will see a difference. Now, in the US, where our book is produced, the law requires that if the effective rate is different from the stated rate, that it should be given, it should be stated somewhere. Oftentimes, companies, financial institutions will state the effective rate, but they'll put it in fine print. Okay, so that it cannot be said that they didn't fully inform you of the effective rate. So effective rates sometimes vary, and the reason why it varies is because sometimes in the calculation, the amount that you receive is different from the amount that is stated in calculating using the stated rate. All right, so your stated rate is also referred to as a nominal rate, and we're going to look at two examples here. So we have two situations where we're using the same set of values. Two banks, one bank we refer to as blue, another bank we refer to as sun. They're compounding at different time periods though. Same interest rate, one is 8%, the other one is 8%, but one is compounding quarterly and one is compounding semi-annually. So because this bank here, a blue bank, is compounding quarterly, their periods, they would have 4 periods, and each time it would be 2%. The other bank that is compounding semi-annually, it would be 2 times per year, and each time would be 4%. So if you use the principle, the same principle for both 8,000, you look up the value on the table. For the first bank, the table factor is 1.0824. For the second one, it's 1.0816. So when you multiply, go straight through, you get 8,659.20 as your compounded amount. In this other one, you get 8,652 for your compounded amount. The interest ends up being 659.20, and the other one 652.80. So even though both banks say that they're paying you the same interest, that's the stated interest is 8%, because the amount of times that they're compounding is different. One is compounding 4 times a year, one is compounded 2 times a year. You will see that the interest varies from one bank to the next. And so that is why by law in many places, they require you not only to just give the stated rate, but you must also give the effective rate. And in this case, they refer to the effective rate as the annual percentage yield, because the amount of times you compound will actually affect what your effective rate is. So compounding quarterly actually works out, if you look at it, because you got 659.20 as your interest, when you put that over 8,000, it works out to 8.24%. Whereas when it compounded semi-annually, you work it out as a percentage of your investment of 8,000, it ends up being 8.16. So the annual percentage yield reflects a higher percentage for quarterly investment versus semi-annual investment. And you will notice, in fact, if you look at this table, that's on page 307 of your text, what can you conclude by looking at this table and what we just did?
Based on what I could see, it looks as if the end balance always has the rate in it.
Okay, but what can you say about the rate and the frequency of compounding? You have annual is once a year, semi-annual is twice a year, quarterly is 4 times a year, daily is every day. So 1, 2, 4, 365. Look at the amount you earn. You have $1,000, you're getting 6% for in each case, but look at the differences. Look at the differences in the effective rate. What is that showing us?
That you earn more quarterly and daily.
Okay, the more frequently you compound, the more frequently you compound, what happens?
The higher the rate.
the more interest
the more interest you get,
you get.
and the higher the effective rate. So even though they all say that you're getting 6%, 6% is the stated rate per annum, but the more frequently you compound, the effective rate ends up being higher and the more interest you actually earn. Okay, so that is why it is, like I said, in some jurisdictions, they require you to not just give a stated rate, but also say what the effective rate is, because if you just look at the stated rate, you will not know for sure. You might want to compare two banks and see which one give the better interest. But if both of them say 6% as the stated rate, but they compound at different periods, the bank that compounds more frequently will actually have a higher effective rate than the bank that compounds less frequently. So frequency of compounding affects your effective rate and also the amount of interest you earn, as well as the amount of interest you pay. Because of course, if you actually have a loan,
I just gonna ask you about that.
yeah, it also affects how much you pay. So it goes both ways. Okay,
So-
both ways.
So question, so if you have a loan, like you pay it monthly, it'd be more effective to you if you pay it, let's say, bi-monthly or even weekly.
Well, with loans, the thing that really saves you is if you could pay on your
Principal.
your principal to reduce, yeah, the amount of
balance.
interest, yeah, you have to pay on the balance. So if you put something on the principals, that helps. All right.
Okay.
Okay. All right. So we mentioned here daily in the last section where you see that you earn more. The most it could be is daily, because you have yeah. So if you look here, there is a table in your book on page 308 for daily compounding. All right. So you really don't have to do much with that, because it's simply, you just have to, the number of periods would be whatever years you have, and the rate would be whatever is given. You just look for that on the table. So in this case, it says $1,500 compounded daily for 5 years would grow at 7%. You need to work that out. So 5 years, 7%, you simply go to the table, look for 7%, 5 years. In this case, it's 1.4190. And you multiply that by the 1,500, and you get your compounded amount. Okay, so there is a table for compounded daily. The other table we looked at, you have to work out the number of periods and the rate per period. But in the case of the daily table, whatever you're given in terms of years and interest, you simply look for that on in your table and use that table factor to multiply the principal to get your compounded amount. All right. So let's look at these two questions here. The first one is asking to calculate the effective rate of interest for 1 year. So you have a principal of 15,500. The interest rate is 12%. It's compounded quarterly. You want to work out the effective rate. So first of all, you need to find out how much interest is earned for 1 year of investment. The effective rate is usually based on a single year of investment. So you need to find the number of periods and the rate per period. So in the first one there, how many periods are we looking at?
Four.
4, because it's 1 year compounded quarterly. That would be equal to 4 times 1, which is equal to 4. And what's the rate per period?
3%.
3%. That's 12 divided by 4. 12% divided by 4 is equal to 3%. Okay, so the table factor then. Table factor. You said 12 at 4%. Anybody could see what that table factor should be?
One point 1255.
What would you say it was again? It was 4.
3% for frequency is
3%.
4 and at 3%.
Okay, and you said 1 point what?
1255.
1.1255 for 3%. Okay, equals 1.1255. So your compound amount or future value would be equal to 15500 times 1.1255, which gives us how much?
$17,445.25.
Okay, so the interest is
$1,945.25.
1,900.
45,
Mm-hmm.
25 cents.
Okay, so how are we going to work out the effective rate now?
$1,945.25 divided by 15,500.
Mm-hmm.
$0.1255.
Okay, and so when you change that to a percentage, what do you get?
12.55.
12.55%. Okay, and the stated rate was how much? How much was the stated rate for this question?
It's the 12%.
12%. So you see the effective rate end up being slightly higher than the stated rate. 12 point, you got just a little over 0.5% higher because of the fact that you're compounded 4 times a year instead of just a single time for the year. If you only compounded once a year, which was annually, then your effective rate would be the same as your stated rate. But because you're compounding 4 times a year, you get the benefit of that multiple compounding because you're adding interest 4 times to your principal. So you end up with a better return on your investment for compounded multiple times. Okay, so the more frequently we compound, the better the effective rate is. Okay, so 12-6, they want you to use the table to find out what $700 would grow to at 6.5% per year compounded daily for 7 years. So in the case of the daily compounding, we just need to know the percentage for year and the amount of years. Let me see, do we have that on this table? 6.5 for 7 years. Okay, what would be the table factor here? 6.5 for 7 years.
1.5761.
Okay, so we'll just simply say 700 times 1.5671, and that gives us
$1,096.97.
97 cents, you said?
Yes.
Okay. All right. So with the daily compounding, we simply just look up the rate and the number of years to get the table factor. I multiply that table factor by the principal, and that gives us the compounded amount. They ask you what would it grow to? Yes, so what would it grow to would be $1,096.97. If they wanted the interest, then you would subtract the 700 from that to get the amount of interest. Okay, now, so we've been looking at future value. Now with the future value, we know the present amount, and we want to find how much the money will grow to in the future. So you have a starting amount, and that table helps you to work out how much to grow to in the future based on the interest rate and the number of times you're compounding. Now, your book also has a reverse concept called present value. So the present value is different from the future value. The present value is saying to us, we know the future value and we want to find the dollar amount that it is worth in the present. So you have a goal you want to achieve. Let's say you want to buy a car that costs $30,000, but you want to buy that 4 years from now. You know what the bank is paying for interest. You know how frequently they are compounding. You want to know how much must I invest today so I can get that $30,000 in 4 years' time. So that's the concept of present value. So what present value must I have in order to achieve an stated value in the future? Okay, so that's your present value. Your future value or compound amount, you know what you have now, today. You want to know what will it grow to in the future if I invest it. The present value, you know what you want in the future. You want to know how much must I invest today to get that future amount. Okay, and so the two are kind of related, but they have different objectives. So the working for present value is similar, but the table is, the figures are different. You go through the same procedure. There's also a formula that you could use. Okay, so you'll see the formula here. So it's the amount you want to achieve over 1 plus interest times, sorry, to the nth power. So once you know how to work out future value, it's the same steps, but you're using a different table. And this is the table here for present value. Now, you will notice if you compare, if you look at the values on the present value, what do they start with? All of them start with what?
0.
0 point. Now let's see if we could find the one for the future value. Notice what these start with.
1.
1 and is only 1.
1 point.
Okay, but if you go all the way to the last
Uh,
column,
It go from 1 to 17.
okay, so it's above, they all start with a 1 or above. So that's because your money is going to be growing with the future value. You have a certain amount now and you want to know how much to grow to in the future. So with the present value table, you have a projected amount and you want to know how much you must invest today. So what you want to invest today is going to be less than what you want to achieve in the future. So therefore, the values on that table is going to be less than 1 because what you have to invest today is going to be a lower amount than what you want to achieve in the future. So these values all are going to start with 0 point. So if you know that you're trying to find future value and you have this table, you know you're on the wrong table because future value or compound amount, your value should be growing. So you should be getting table factors of 1 point something and above. But if you know your future value, you know what you want to achieve and you want to find out how much must I invest today to get it, then you're looking at a table where the values have to be less than 1, as these values are, okay? So this here is an example of a type of question that you will be using the present value table for. So this person needs $20,000 for college in 4 years' time. She can earn 8% compounded quarterly at her bank. How much must she deposit at the beginning of the year to have $20,000 in 4 years? So of course, if you want to get 20,000 by investing something today, you're going to have to invest less than 20. You're not going to be investing 20 or more. It has to be, you're trying to get 20. So you're going to start off with something less than 20. So the number of periods before it's done quarterly. So it's the same process. Number of periods will be 16. The rate per period, same process again, is 8% for the years, compounded quarterly. So that's 8 divided by 4 is 2. So you go to the table, you look for 16 periods, 2%, 16 periods, 2%. So that would be, 16, oh, this table doesn't have 16 periods, 2%. But, okay, this one stops at, let me see, in your book, page 311. Okay, the book have it. Okay, so this one I have is a shortened version of it. But if you look in your book, 16 periods at 2% is 0.7284, which is what they have here. All right, so to find the present value, you just multiply the amount you want, which is 20,000, times that 0.7284, you get 14,568. So what that is telling us is that if you invest $14,568 today, and the bank promised to pay you 8% compounded quarterly, in 4 years' time, you will get that $20,000. Okay, so that's the present value you need to invest in order to get 20,000 in 4 years' time. All right, so let me see. All right, so let's look at a few of these. So we're going to, let's see. Okay, so look at 12-7. So it says complete the following using present value table. Okay, I guess we could try the formula too, but let's look at the first one, 12-7. What is the number of periods for that one? Number of
16.
periods? 16, okay, because, oops, what am I doing? Okay, 16, that's 8 semi-annual, that's 16 periods. What's the rate per period? Rate per period?
1.5.
1.5? Mm-hmm. Okay, 1.5%. All right. Now, my chart here, let me see, doesn't have that, doesn't go to 16. But in your book, anybody have the book to tell me for 16, this would be on page 311 for 16 periods at 1.5%. What's the table factor? Anybody with the book?
0.7880.
Okay, 0.7880. All right, so we're going to multiply that 6,000 times that. So how much money we need to invest today? To get that amount.
4,728.
Okay, 4,728. Okay. All right, so let's try the formula with this. So the present value is equal to A over 1 plus I to the nth power. So the amount we're trying to get is 6,000. And then it's going to be 1 plus the interest in this case is 0.015. And we want that to that's the 16th power. Okay, so that would be 6,000 over 1.015 to the 16th. So that one now will require you to use your scientific calculator to work out what is 1.015 to the 16th. All right, so 1.015. Okay.
Mr. Allen, earlier you were saying about the power key, right?
Mhm.
And I don't see that on my calculator.
Okay, you using a cell phone or using a calculator? Oh,
Scientific calculator, the Oxford calculator.
all right, now, hold on, let me just write what I have here. 1.2689855. Okay. All right, now you see a key like this looking like that?
Yes.
Yeah, you could use that. So you put in the 1.015, press that key and then put the 16 equal. You got that? You got the answer? The 1.268.
I am trying it right now.
Mhm.
Yes.
Yeah, okay. So different calculators have the power key labeled differently. So some have X to the Y, some have Y to the X, some have this here. And I think there might be one or two other ways it's stated. I think they might have Y to the N or something like that, but it varies. So you just have to check around with your calculator and see what it is. So once you get this now, then you're going to divide the 6,000 by that. And that should give you the answer we had there. So if you go back to, let me go back to my calculator and 6000 divide by 1.26. Okay. Yeah. So once you do that, you should get roughly the same answer that we had for the question, but you'll get a few cents. All right. So you get 4,728, and it's look like 51 cents or something like that. Okay. Which is slightly. Of course, the formula would be more accurate than the table because the table rounds off the values to 4 places, whereas if you use the scientific calculator, it would go to far more places than the 4 places that the table rounds off to. Okay. All right, so I'll just look at that first one. You should get the point with it. So we're looking to find how much you need to invest today to get a certain amount in the future. Now, the challenge oftentimes is
Sorry, Mr.
reading it.
Allen, can you go back to that slide, please? Thank you.
Okay. So, like as I was saying, the challenge is to actually read a question and determine what is asked. So I have 3 questions here. And so I'm going to call on you to tell me whether we're looking at future value, present value, or what was the third thing we did? We did annual percentage yield. Give you a minute to read through them, and then I'm going to call 3 persons to tell me what you've been asked to do for each one. Okay, Mr. Butler. First one, what do you ask for there? Future value, present value, or annual percentage yield? Mr. Butler, you with us? Hello, the butler. Okay, butler disappeared on us. Okay, Ms. Thompson, what'd you say about that first one?
First one, so I'm long to spend you.
Could you repeat that?
No, I was reading it again.
Okay. Future value,
Yes,
present value,
they
or
asking for future value.
future value. Okay. Are they looking for how much the money will grow?
Sorry,
to in,
present value, how much you will have to invest today?
right. So that's the key thing that you have to look at. Invest today. So if the question is asking how much I must invest today, that means I want the present value that I must invest in order to get a certain amount in the future. And you could see here, it says that they will need this amount in 15 years. So in order to get that in 15 years, I need to know how much I must invest today, which is the present value. Okay, so that was Ms. Thompson. Ms. Heald, what about the second one, 12-13?
Future,
Okay, future value. Okay, it says the person owns a shop, loaned 40,000 to someone. The person plans to repay at the end of 8 years with 6% interest compounded semi-annually. How much will the person earn at the end of 8 years? So we want to know what the future value of that investment or that loan will be. All right. So that was okay, Miss Hill. Mr. Butler, are you there? You know? Okay, Miss Knowles,
Yes.
the last one. What are we looking for?
The same APY thing.
Okay, annual percentage yield.
Yeah, that.
Okay, so I'm going to give you all 5 minutes to work those 3 out. And then I'll call on persons to tell me what they got. Okay, so do the calculations for those 3.
We need chart,
Repeat that.
charts.
Oh, you need the chart. Oh, you don't have the booking. How are we going to do that then?
I think we should just work all together.
Either me. I don't have the book either.
Oh boy. Okay then. I really wanted you all to practice on your own, but anyway, I guess
Yeah.
we have to do that then. Okay.
Anyway,
Okay. All right. So let's look at the first one. Okay, so the first one we said is supposed to be present value. So in any case, whether we're doing future or present, we need to know the number of periods and the rate per period. So what is the number of periods for number 1?
15 times 2. 30.
Okay, it's semi-annual for 15 years, so that would be 30. And the rate per period?
Four.
4%, okay.
Ms. Allen, you could explain how we get the rate again, please?
Okay, it's it is 8% for the year,
Mhm.
but it's compounded semi-annually, so you're doing it twice a year. So if you're
Oh,
doing
8 times
twice
2.
a year, you're gonna have to divide by 2. So it's 4% each time, and 4 2s are 8. Okay, so we need to find a table factor then for 30 at 4%. Oh, no, I don't have that on the for the table factor. This is present value. So you'd have
It's
to look in the book for that.
4% at 30 is 3.2434.
You're looking at the
Sorry,
present value of
3
future.
point.
Remember now, this one is present value. You're looking at the present value table or the,
I was looking at the wrong table.
yeah, we need to look at the present value table.
Hmm.
Remember the present values all start at 0 point something.
Okay, 0.3083.
Okay, 0 3083.
3, yes.
Okay. So so therefore you would then say 225,000 times 0.0, sorry, not that, 0.3083 is equal to
69,367.50.
9,000.
367 and
Mhm.
50 cents.
50, okay. All right. So if they invest 69,367.50 today, and they get what's this, 8% compounded semi-annually, it will grow to that $225,000 in 15 years. Okay, so that is for the first question. Okay, so the next one we said is looking at how much this person will receive at the end of 8 years. So we're looking for the future value. So we still need to know what is the number of periods and the rate per period.
Will a number of periods be 4?
Oh, you're back with us.
Yeah, sorry.
Okay, I have to put you back in. I had marked you absent. Okay, Mr. Butler is back. Okay, sir. Okay, so how many periods you said, Mr. Butler?
4.
4. This is 12, 13. We have 8 years, and you're compounding semi-annually.
Sorry, I was dividing. I need to multiply, so that'll be 30. 16.
With 16.
Times 2. Mhm.
Okay. 16 periods, and the rate per period, Mr. Butler, would be
6 divided by 2 is 3.
okay, 3%. All right. So now this time we are dealing with future value. So we need to look in the future value table and not the present value table. And remember the future value table, those all values start with 1 or more. Okay, so we're looking for 16 periods at 3%. Periods at 3%. What's that equal to?
What page is the future value table on?
Hmm?
Which page is that on? The table,
305.
305.
$1.6047.
Okay. So we're gonna now multiply the 40,000 times the 1.6047. And so that gives us
$65,880.
okay. Now, of course, if you want to, you could play around with the formula and try to see if you get those same answers, because it's sometimes useful to be able to use the formula, because like if your book doesn't have the full table or it doesn't have the values you're looking for, then it's handy to use the formula to work out those. Okay. Now the last one, 1214.
I have a something. I'm not getting that total. That
The
you have.
65, you mean the 65,880?
Mhm.
Okay. I don't know. I am going up based on what I was told, but let me double check.
64,180. 64,188. That's what you're getting?
Yes.
Oh, okay.
My bad,
All right.
sorry.
Cross that out then. All right. So you said 64,188?
Yes.
188. Okay. Yeah. All right. $64,188. Okay. So this third last one here, then we're looking for the annual percentage rate. So we still need to go through the process to find out how much interest is earned for a year. So we need to know the number of periods. In this case, it's just 1 year. So number of periods would be what? Hmm?
One.
What? How frequently are
Would
we
it be-
compounding?
Would it be 4?
4. 4. Yeah.
Quarterly. Okay.
Okay. 4. Number of periods equals 4. And the rate per period?
2.
2. 2%. All right. So this is compound interest, that's future value. So the table factor then is equal to what's the table factor? Hmm? 4 at 2% compound interest. Nobody have the table?
What page the table on in the book, Mr. Allen?
30, what page is that again? Future value is 305.
$1.0824.
Okay. So what are we going to do next?
Multiply the true factor by the principal.
Okay, so that's 50,000 times 1.0824. And what does that give us?
$54,120.
Okay, so that is the compounded amount or the future value, but they want you to work out the effective rate. So in order to work out the effective rate, what's our next step?
Subtract the 50,000 from 54,120.
Okay, so you're gonna have 54,120 minus 50,000, and that gives you
4,120.
okay. So your interest is 4,120. So to find the effective rate then, or the annual percentage yield, APY,
$4,120 divided by 50,000, and then times it by 100 to get the percent. $8.24%.
and the stated rate was what again?
8%.
8%. Usually your effective rate, your APY is slightly higher than the stated rate. Oh, yeah, so 8.24%. Yeah, sounds good. Okay. So that's that. Okay, so all right, so what's going on here now? Homework, okay. Your homework is page 319. I think the questions are right here. 1 to 8. Question, okay, so page 319 is here, so you'll get a copy of that shortly. And then we're supposed to do this test 3. So that's coming to you. That's 8. Okay. All right, so test 3 was supposed to be today, but because we were a little bit behind, we're trying to catch up. So I have it to be emailed to you by midday today. You should get that. And I want you to print it, answer it on the printed copy, and email the copy upon completion. It's due by end of Wednesday this week. So you have up until Wednesday to finish that off. And that's just, I think that's just based on chapters 9 and 11, I think. But you'll see it on the test itself, 9 and 11. Okay. And then we're finished with chapter 12. And so the homework for chapter 12 is page 319, numbers 1 to 8. And the questions are right here. And there's the answers. Then we move on. Okay, now to wrap up, as I said before, we all the classes after today will be on Saturdays, and we'll basically try to follow schedule as much as possible. I sent your tests to you by email not a few minutes ago, so you should see that in your email. Let me see here. Yeah. Okay, so all those who did the test, you should see that in your email. And I want to spend some time now looking at that test. And I think I've said it already. The persons who have been doing the homework consistently have been doing better on tests. That homework, you need the practice to assist you. So hopefully now that we don't have midweek classes, you have a few days in which you could probably try to see if you could work in some time to do the practice. The answers are there. If you can't get the answer, then you could always make contact, or next class you could ask, for explanation as to how an answer was arrived at. So you could see what strategy was used to solve questions. The more exposure you get to answering questions and attempting on your own, is the better you're able to tackle, especially questions in your final exam. Because we're doing this virtually, I kind of don't like that in a sense, because you really need to work to time. You see, when you are able to do a test at your own pace, is different from when you actually have an exam in front of you and you only have a limited time to do it. And so that's why doing the homework and practicing and seeing how answers arrive, that develops your skill, so that when you go to an exam, you are more able to tackle questions, and you don't have to waste time trying to figure out. The more experience you get, the better you're able to answer questions and at greater speed. Okay, almost like driving. Okay, more practice makes you more adept. So please, as much as possible, even if you miss some of the homework that you didn't do in the past, you could still do it, send it to me, and I could credit you, because I really want you to try and get the practice, because that final exam is heavy in terms of weighting. It's 60%. Okay, so you could do very well in the term, but if you don't have that practice to really, get you prepared and able to tackle the questions in 3 hours, then it's a challenge. Now you have one more face-to-face exam. That's the next midterm, which I think is December 4th, I think it is. Let me double check here. December 4th, yeah. So that will give you one more time to actually sit and work to time, okay? But all those tests that you did, you have test 1, test 2, and the midterm. I would suggest you could probably just try doing them to time. I think the test 1 and test 2 is supposed to be like half an hour or something. The time is on the paper anyway. The midterm is supposed to be 1.5 hours. So if you try to just do them, see if you could cover the answers, do them on your own, and try to pace yourself so that you could work to time. Because when you do it not timing yourself, it actually does you a disservice when you actually have to do a long final exam where you have to work the time. So that's something I suggest you try and do as much as possible. Okay, so all of you should have your paper, either what I emailed to you or the actual paper that you did. And so I want to look at the paper so you could see where we went wrong, or midterm number 1. Now, a lot of us seem to have problem with these fractions. I don't know why. Even though some persons did well in other areas, the number of you messed up with the fractions. And one of the things I need you to remember is that when you're adding and subtracting fractions, the denominators have to be the same. Some people just add 3 plus 2, 8 plus 5, and got what, 5/13? No, you don't add fractions like that. They have to have the same denominator. So you have to find a common denominator for both. So in the case of number 1, A, the common denominator is 40. Okay, you're looking for a number that could divide, that both of those denominators could divide. So 40 is a number. And so you have to convert the numerator to match that denominator. So 5 8s are 40, so 5 3s would be 15. 8 5s are 40, 8 2s are 16. So that would be 31/40 is your answer. You can't simplify that any further. So that's the result there. In the case of number 1B, we have okay, 2 and 1/8 minus 11 over 12. So the common denominator there. Now, what we could do is we could convert that first one to 816 as 17 over 8 minus 11 over 12. And the common denominator would be 24. Okay, so another time we're adding fractions or subtracting, we have to find a common denominator and convert the numerator. So 3 times 8 is 24. So we have to multiply the 17 by 3, which gives you 51. And then 2 12s are 24, 2 11s are 22. And then you subtract 51 minus 22 is equal to 29 over 24, which gives you 1 and 5 over 24. Multiplication is a little easier, but if you have mixed numbers, you have to convert them. So this would be 5 2s 10, that's 13 over 5. And then 5 3 is 15 and 1, 16 times 16 over 3. Now you could cancel. There's nothing here to cancel. So we just multiply 13 times 16 and 5 times 3. 5 3s are 15. And then we multiply 13 times 16, which is 208. And then 15 goes into 208 13 times, and that remains 13 over 15. The next one, again, division. You have to convert mixed numbers to improper fraction. That's going to be 29 over 12 divided by 3 over 8. Then you rewrite it, 29 over 12 times 8 over 3. You can cancel here because 4 could go into that 2 times, 4 into that is 3. Okay, 2 times 29 is what that is, 58. 3 3s are 9. 9 to 58 goes 6 times. Remainder 4 over 9. I don't think anybody got number 2 correct. It wasn't that. Okay, so it says Travis, Shanika, and Perry entered into a partnership. Travis owns 1/3. Shanika owns 3/5. How much does Perry own? So altogether, how much do they owe? They own. How much do they own altogether? If you were to add up their total.
One whole.
1 whole. So you're going to say 1 minus 1/3 plus 3/5. So if you add up what Perry owns and what Shanika owns and what Travis owns, that would be 1/3 plus 3/5. You're going to subtract that from 1. That will tell you how much Perry owns. So it's equal then to 1 minus, common denominator would be 15. So 3 into 15, 5, 5 1s 5. 5 into 15, 3, 3 3 is 9. Okay, so 9 and that's 1 minus 9, and that is 9 and 5 is 14 over 15. So 1 minus 14 over 15 If you change 1 into 15, how many 15s would that be? You need a common denominator.
15 over
15
15,
over
right?
15 minus 14 over 15 equals 1 over 15. So the answer is 1 over 15. Okay, so that's the first page. It was 11 points in total. All right, so next page. Wow, there's another one that was rough, it seems. A trip from Miami to Tampa takes 4.5 hours by car. Assume we are 3/4 of the way there. How much longer will the trip take? That's almost like saying you have $8 and you spend 3/4 of it. How much money you have left? Anybody could answer that? You have $8, but you spend 3/4 of it. How much money you have left? Hmm? You had $8, but you spend 3/4 of it. How much you have left? Hello?
We could borrow from it.
No, I'm
Yeah, but-
asking you a question. Suppose you had $8 and you spend 3/4 of it.
$2.
How much? You have $2 left. How do you get that?
Because half of it would be 4.
Say it again?
Half of $8 would be 4.
Uh-huh.
So a quarter more would be 6.
Mm-hmm.
$2 there.
Okay. Well, this question is almost the same thing. If you want, you could find half of 4.5 and then find half of that, add it together and subtract it from 4.5. So basically, we are trying to find out here, you're trying to find out what is 3/4 of 8. 3/4 of 8 is 6. So if you spend $6, then you have $2 left. So you need to find 3/4 of 8. And to find 3/4 of 8, you would say 8 times 3/4. 8/1 times 3/4. 4 into 4, 1. 4 into 8, 2. 2, 3, 6. And then you say 6 from 8 is 2. So basically, it's the same thing you're doing here. This thing is 4.5 hours, but you already covered 3/4. You 3/4. So how much longer would be? So you have to say now 4.5 times 3/4. That's 9/2 times 3/4. Can we do any canceling here? Let's see. No. So that's going to be 27/8. All right. So you have covered that portion of the journey. So that's equal to 3. And what's that? 3/8. That's how much you have covered. But now you want to know how much more is left to cover in terms of time. So if you want to find out how much more is left, you know how much you have covered. You have covered this amount. So now you're going to say 4.5 minus 3 3/8. Okay. So sometimes if you kind of simplify the question in your mind and see what you would need to do a simpler version, you follow the same steps to do the question. So 4.5 minus 3 3/8. You're gonna, if you want to convert them, that would be 9/2 minus 3 is 24. That's 27/8. The common denominator is 8. So you're going to use 8. You're going to subtract. So 8 here. 28 is 4. 4 9s, 36. And that would be 27/8. When you subtract, you get, what's that? 9/8, which is equal to 1 1/8 an hour or hours. Okay. So that's how you would solve something like that. So you multiply the 3/4 time the 4.5 to find out how much you covered. So you're trying to find 3/4 of 4.5. And once you get your answer, then you're going to subtract it from the 4.5 to find out how much is left to cover. Okay, the next one, straightforward, 58.237. The next one, 13.09. Next one, 575/1000. Okay, this one here, I guess we didn't do this all the way thing, but basically it's supposed to be 8 times 6. 6 8s are 48. That's just a rough estimate. And then the actual answer, you're going to multiply 8.42 times 6.3. And the actual answer should be 53.046. Any questions with this page? No? Okay, so we'll move on then. Okay, the first one here, part A should be 2550. You move the point 2 places to the right. The next one you're going to divide, but so you're going to move 3 places to the left. So it'll be 43.8576. 8576. Okay, this one says the person bought a desk for $900, pays $100 a month, charge 1.5% on the unpaid balance. Okay. So you find 1.5% of 900, you should get $13.50. Okay. And you're paying $100 a month. So your reduction in the balance would be that $13.50 is interest, goes to the company. So the rest that's left, all of the 100 would be $86.50. And so you take that away from the 900. So that would be $813.50. Okay, 38% of 900, that should be 342. You're trying to find the base here, so that would be portion over rate. So it's be 55 over 0.4, which works out to 137.5. And then this one is 430 over 5,000, which gives you, well, we could multiply by 100 to give you 8.6%. Okay, number 10, you are told that in 2003, sales was 300,000. It went up by 40% in 2004. So what are the sales in 2004? So you have to find out how much it went up by. So that would be 0.4 times 300,000, which gives you 120,000. And then you add that to the 300,000. to get 420,000. And then this last one was 47 minus 3Q equals 21. Any questions there? No? Okay, so move on. Okay, I think most people got the equations. It should be 2y equals 14 minus 4, 2y equals 10, y equals 10 over 2 equals 5. And then 12t plus 24 equals 84. 12t equals 84 minus 24. 12t equals 60. T would be equal to 60 over 12 equals 5. Okay, number 13, we had, we could use Y to represent the sales for Electronic Haven. So based on what we have here, we could say 7Y. One sells 7 times as many as the other. The difference is 300, so that's minus Y equals 300. So 6Y equals 300. So Y would be equal to 300 over 6 equals 50. So 50 would be for Electronic Haven, and 7 times 50 equals 350. So that would be for B and W. So B and W would be 350. What's this? Cameras. And the other place would be Electronic Haven. Would be 50 cameras. Okay, the next one, you just basically have to decide whether you're going to add or subtract to get your final balance. So the first one you're going to subtract, so you get 701.92. Then you're going to add the deposit, so that's what's this here, 881.92. Then after that, you're going to subtract the payment. You made a payment, so that's subtract. So that's going to be 742.92. Then you're going to make another payment, so you're subtracting again. That's 644.25. And then you're going to make a deposit. And deposit 625. So your total at the end would be 1269.25. Okay, so that's. Any questions with that page? No. Okay. So moving on. All right. So in this question, we're doing the reconciliation. So we have checkbook balance. So we're gonna put check balance. Sorry, checkbook. Okay. And where's the other one? The bank balance. Okay, bank. Okay. What I did? No. Okay. The bank balance. So checkbook balance was 63. 121.89. The bank balance was 5920.10. Okay. So we had $35.10 was what was that again? 35, that was interest. So you're gonna add the interest. So interest you add, that's 35.12. And then on the checkbook side balance, you're going to subtract, there's a fee, a service fee. So service fee is something that you subtract. So you subtract that, you add the interest, and that service fee was 10.75. So at the end, you should have 6346.26. So on the other side, the bank balance side, you're looking at a deposit in transit. So you're going to add that deposit in trans. So you're going to add that. That was 961.79. And then the outstanding checks. Outstanding check. We had 2 of them. Okay. Okay, the 2 checks. One was for 68.35. So you subtract that 68.35, and another one for 467.28. So when you add and subtract, you add the deposit and transit, subtract the outstanding checks, you should get 6346.26. So the two sides should be balanced with that amount. Okay, 16, you're asked for the dollar markup. You buy some for $4.50 and you sell it for $697.50. So you're going to subtract, you get 247.50. And to find the percentage markup, you put that 247.50 over the original price, which was $4.50. And that should give you 55% when you work it out. Okay, in the last one on that page, you bake 100 bagels, you have 20% spoilage, they cost 48 cents, and you want 70% markup. So first you have to work out what the total cost is for 100. So 100 times 0.48 gives you $48. And then you want a markup of 70% on that. So you find 0.7 times 48. And I think that gives you 3160. Sorry, 3160? No. Let me double check that. Okay. 0.7 times 48, 3360. Okay. And so your total earnings then you expect is, when you add the 48 plus the 33.60, you want to make a total of $81.60 from, that's your total selling price. Total selling price is that. But you can't sell all because you expect 20% to spoil. So you say 100 times 0.2 equals 20. So 20 will spoil. So the saleable amount would be 100 minus 100 minus 20, which is equal to 80. So to work out the price, then you would have to put the total sales that you expect, which would be 81.60 over the amount that you expect to sell, which is 80. And that gives you $1.02. Okay. All right, any questions on that page? I guess not. Okay, so move on then. All right, now this one, we look at the difference in time. I suggested you do that first before you do anything else. So you go from the 18th to the 24th. So you're looking at 6 days. Then from the 24th to the 29th would be 5 days. Then from the 29th to the 5th is 7. Because we are looking at, which month is this? This is March. That is, March would have 30 days of September, April, June, November. So March of 31 days. So you have 2 days left in March and then 5 days into April. So that's 7, yeah. And then from the 5th to the 4th to the 9th is 4 days. And then we have, when we add this up, 6 and 11 and 11, 22. And this is a 28-day cycle. So we have another 6 days left in the cycle. All right. And then once we have finished that, we now work out how much money is going to be in our balances here. So we start off with 800. Then you made a payment of 60, so your balance dropped to 740. Then you bought something for 250, so you're now going to add 250 to that, so that's been 990. Then you made a payment of 20, so you're going to drop to 970. Then you made another payment. Sorry, you need a purchase of 200, so you're going to go up to 1170. All right. So the 6 goes with the 800, 5 with that, 7 with that, 4 with that, 6 with that. So you multiply them out. So that first one should be 4, that's the extension, 4800 and 3700. Then what's this here? 6930, 3880, and then 7020. Add it all up together, you should get 26,330. And you're going to divide that by the 28. So 26,330 divided by 28 gives us 940.36. And that's your average daily balance. And then you find 1.5% of that to find the amount for the charge for that month. So 0.015 times 940.36 gives us a charge of $14.11. Okay. The next one, 16,000 times 0.03 times 8/12. And that gives you $320. Okay, this one you have from May 6th to August 14th. So that's 226, 126. So the difference is 100 days. And then to find the interest, it would be 20,000 times 0.07 times 100 over 365. They told you to use the exact interest method. It's 100 over 365, and that works out to 383.56. So that's what would go in here. And then the maturity value, you're going to add, you're going to say 20,000 plus the 383.56 gives you 20,383.56. And that's what should go in that spot. Any questions there? No? Okay, so we're on the last page then. All right, so the last page we have, okay, we have to find the rate. So rate is equal to interest over principal times time. So that's 280 over principal 6,000 times 180 over, sorry, what? Yeah, 180 over 360. And so that works out to 9.3%. 9.3%. Okay, and the last question we have, okay, this person borrowed $4,000 on a 60-day note, made a payment on day 15. So the first payment was day 15, so you say 4,000 times 0.04, 4% interest, times 15 over 360, and that gives you $6.67. That's the interest due for that first payment. And you take that interest out of the $700 payment that she made. And so $693.33 is left. And that will now reduce the principal from 4,000 minus the 693.33. And so the new principal now is going to be 3306.67. So that's stage one. So another payment was made on day 40 of $2,000. So the principal is now 3,306.67. So 3306.67 times 0.04. This time you have gone 25 days since the last payment. So that should be 25 over 360. And that works out to $9.19. Then you made a payment of 2,000. So you're going to take that interest out of the 2,000. So 2,000 minus 9.19 gives you 1990.81. And this is what you're going to use to reduce the principal. So I'm going to go over here and say now 3306.67 minus 1990.81. And so your principal here is now going to be 1315.86. So that's end of stage 2. So you made no more payments. So you just have to pay it off at the end of the period, the end of the 60 days. So you're going to find the interest due for the last portion, which would be 1315.86 times the interest is 4%. And you have 20 days left because you already made payment for up to 40 days. So 20 out of 360, and that works out to $2.92. And so the amount you owe at this point would be the 1315.86 plus the 292. So your final ending balance should be 1318.78. That's it for that. Okay. Now some of you may see some follow-through points, FT. So you might have done 1 or 2 calculations incorrectly. So you still get follow-through if you did the right method, even though you may have the wrong number. So if you see a question is worth 8 marks, but you got 7 or 6, maybe you did some things correct, but you made a mistake here and there. And so that's why you didn't get the full points. Okay. So I don't know if you have any questions about any of them, but if not, then if you choose to, if you choose to, you have another test that I sent to you. That's exactly the same format as this one for midterm. It's optional, you don't have to do it, but it would be good for you to do it because the more practice you get, the better skilled you become in tackling these type of questions. And your exam is going to be made up of questions that's very similar to these. So if you can do it, it would be to your advantage. So even if you get 90% or whatever score you get, it's still good to, do it. And if you do it, I want you to please print the test, answer it on the printed copy, either take a picture or scan it back to me. And I need to get that by Friday so that I could mark it. I'm not sure I'll be mark it for next class, but if I get it by Friday, I will average whatever you got. So if you got 60 and you do this test and you get 100, 100 plus 60 divided by 2 will give you 80. So that would improve your score for the midterm. So apart from the practice, it will also improve your score if you do better on it. And I don't see why you shouldn't get 100 on the makeup because I went through the full paper with you. And I didn't hear any questions, so I can presume that you all understood what was done on this. So all you need to do is basically follow what you see patterned here to try and attempt the questions on the makeup. As I said, it's very similar to the actual test, but I really need you to do the practice to improve your proficiency in tackling these questions. All right. So, well, we went over quite a bit, but I see you're still there. So I don't know if you have any other questions for me, but if not, That's it for today. We meet again next week, Saturday. If you did the homework, please send it to me. I got homework from one person so far. I think I responded to the person, but I haven't seen anything else yet. And also, you have test number 3, which is due on Wednesday. And if you choose to do the, although I strongly urge you to do it, if you choose to do the makeup, that's due on Friday. And then we meet again next week, Saturday.
Hi, Mr. Allen, just a quick question.
Mm-hmm.
Which homework is due today? Chapter
Today,
9?
the
Yeah,
question,
chapter
the
9.
one that we did last class. Yeah.
That's payroll.
Yes. Yes.
What about the promissory notes?
Any homework that you did, you could send it and I'll credit it. Yeah. So the homework that we did last class, we did payroll and a portion of promissory notes. So those 2 are due today. And then you did part 2 of promissory notes today, and along with compound interest. So once you have it done, just send it and I'll credit. I just need you to do the practice. Okay, so even if it's the first class, just email it and I'll credit you the points. Okay. All right, any other questions? Mr. Butler, you good? Oh, Mr. Butler gone again. Okay, Ms. Thompson? Ms. Thompson isn't there?
Yeah, I was, sorry.
Okay, I just checking to see if, all is good with you. No questions?
Yeah, I was just looking over the test that you sent. That's what happened. The question takes so long.
Okay,
Yeah.
all right. Miss Knowles?
I'm good, thanks.
You're good, okay then. All right, Miss Heald?
I'm good.
Okay, Mr. Butler?
Sir.
You saw the tests and you saw the 2 makeups.
Yeah, my inbox is pretty full with your name on
Huh?
it. My inbox is pretty full with your name on it.
I didn't hear what you said,
I say my inbox is pretty full with your name on it.
Oh, you're something else. Okay, so.
So yeah,
Okay.
I got out.
Okay then. All right, so see you all next week then, God's willing. Bye-bye.
No problem. All right, good night.
Okay then.